Hello, welcome. In this video, we're going to talk about how to solve systems of equations, specifically how to solve a system of equations that has a linear equation and a quadratic. This top one, this right here, is my linear equation, and this one, because of this exponent 2 there, is my quadratic. And the same kinds of things apply when you're solving like two linear equations, as we've done before in years past. We can use substitution. And the fact that both of these are equal to y means that these parts here that are equal to y can be equal to each other. And so I can put 2x squared minus 12x plus 17 and set that equal to 2x minus 3. And then I want to get everything on the one side. I'm going to subtract 2x and subtract 2x. That'll eliminate that. I'm going to get rid of that plus or minus 3 by adding 3. Add 3 and add 3. I'm going to put them here by their like terms. Those cancel. And on the right, then I'm equal to 0. And on the left, I've got 2x squared. Negative 12x minus 2x would be negative 14x. And then 17 plus 3 would be 20. And now I'm going to try to find the values of x that make this true. Because all of these have a 2, I think I'm going to try to see if I can solve it by factoring. I'm going to first divide out everything in here by 2, including the other side. And so as a result, I get x squared minus 7x plus 10 equals 0. I've taken out the GCF, divided it out, and now I'm going to see if I can factor this as a trinomial. And so I take my a times c. A is 1 now, and c is 10. And 1 times 10 is 10, and my b value is negative 7. And so I'm looking for two numbers that multiply to 10, that add to negative 7. And I know that 2 times 5 gives me 10, but 2 plus 5 gives me 7, not negative 7. So I need to make both of these negative, because now a negative 2 times a negative 7, a negative times a negative is positive, so that still equals 10. Then negative 2 plus negative 5 does equal negative 7. And so my factors here are x minus 2 times x minus 5, and that's equal to 0. And now I can set each of those equal to 0. X minus 2 equals 0, or x minus 5 equals 0. And that makes that this one is x equals 2, and this one is x equals 5. Now, some of you might be tempted to say, we're done. No, we have two variables in each of these equations. And so we have two x values. We now need to find the corresponding y values. And so I'm going to take my x equals 2, and I'm going to plug it up here for x, right here for x, to find out what y equals when x equals 2. So I'm going to do that. I've got 2 times 2, x equals 2, minus 3. And 2 times 2 is 4, minus 3, and 4 minus 3 is 1. And so y equals that. Y equals 2x minus 3 is that equation here. This equation right here. So I plugged in 2 there, and I got that y equals 1. So one of my solutions is the point 2, comma 1. And then I want to know what happens when x equals 5. So I'm going to do the same thing, but here instead of 2, I'm going to put 5. And 2 times 5 is 10 minus 3, and 10 minus 3 is 7. And so when x equals 5, y equals 7. And I can plug those x and y values into the other equation just to verify that they solve both equations. I think I'll do it for one just to show you what I'm talking about. I can put in y is, let's use this one here just because it's smaller numbers. Y is 1 equals to 2 times x is 2, so I've got 2 squared minus 12 times 2 plus 17. So I'm looking at this equation but putting in the values for x and y from here 2 comma 1. And because I'm doing a check, I like to put a little question mark. Are they equal? I don't want to just assume they're equal because that's not a good habit to get into. I'm checking to see if they're equal. 2 squared is 4 times 2 is 8 minus 12 times 2 is 24 plus 17. Now 8 minus 24 would give me negative 16, and then I'd have the plus 17 on the end, and negative 16 plus 17 equals 1, which, sure enough, is equal to the 1 that we have on the other side. So that works, and you could find that 5, 7, if you plug that in, would also work. I want to say one more thing really quickly before we move on. This is a parabola. The graph of the quadratic is a parabola, and the graph of the linear is a line. And so having two solutions is one possibility when you're trying to solve a system of a linear and a quadratic. You could also have perhaps maybe just one, where it just touches that parabola in one spot. And then you could possibly also then have a scenario where you have the parabola here and you have the line that goes underneath it, and they never intersect. And so here we'd have two solutions, here we have one solution, and here we would have no solutions. All right. So 2, 1, and 5, 7 are the values that we found for these problems.